Hey everyone, today we are diving into the world of machine learning or ML, a fascinating topic that's changing the way we live and work. But don't worry, we will keep it simple and fun. By the end of this video, you will have a solid understanding of what ML is and the different types of ML. Let's get started. Machine learning is a type of artificial intelligence where computers learn from data and make decisions or predictions without being explicitly programmed. In simple terms, it's like teaching a computer how to recognize patterns in data and use them to make smart choices. Machine learning can be broadly classified into three main types based on how the model learns from data. Let me explain each one of them. We will start with supervised learning. In supervised learning, the model is trained using labeled data. This means that each input in the dataset, the output, is already known. The goal is for the model to learn the mapping between the input and output so that it can make predictions on new or unseen data. So, how it works? The model is fed a dataset where the correct answers are provided and it learns by comparing its predictions with the actual outcomes and adjusts its parameters to minimize the error. You can see classification and regression falls under supervised learning. Classification is in predicting categories, for example, spam or not spam in emails. Regression is in predicting continuous values, for example, predicting house prices. Supervised learning use cases are images classification, fraud detections, medical diagnosis like cancer, and speech recognition. So we'll next move to unsupervised learning. Unsupervised learning deals with the data that has no labels. The model tries to learn patterns and structures from the data without any predefined categories. The goal is to identify hidden structures or groupings in the data. So how it works? The model is given a data set without any labels or predefined answers. And now model tries to discover the underlying patterns, similarities or anomalies in the data. In unsupervised learning, clustering and dimensionality reductions falls under this. Clustering is in grouping data points into clusters based on similarity. Example, customer segmentation. And dimensionality reduction is in reducing the number of features in data while preserving important patterns. Example, principal component analysis or PCE. Unsupervised learning use cases are market basket analysis, anomaly detection, document clustering, and data compression. The final one is reinforcement learning. Reinforcement learning is a type of learning where an agent learns to make decisions by performing actions in an environment. The agent receives feedback in the form of rewards or penalties and aims to maximize the cumulative reward over time. So, how it works? The model or agent interacts with an environment by performing actions, and after each action, the agent receives a reward, which is positive or negative, and the goal is to learn the best strategy or policy to maximize the total reward. So in this case, examples are Markov decision process. These are used to model decision making in reinforcement learning problems. And Q learning, a method where the agent learns an optimal policy by maximizing rewards. So use cases are in reinforcement learnings is, for example, a robot learning to navigate or autonomous cars driving. So that's all about the types of machine learning. Let's see a simple example how the supervised learning process works. So we can see the diagram here. On the left side, we see the label data, which consists of images of a cat and a dog. These images are labeled with their respective categories. Cat and dog label data is crucial because in supervised learning, the model learns from this data by associating the input or image with the correct output, which is called label. In the center of the diagram, we have a model. The model is a machine learning algorithm that learns patterns from the labeled data. It takes the labeled images, in this case cat and dog, and identifies the distinguishing features of each class, example shape, color, size, during its training. The model learns to recognize and classify images based on the patterns found in the label data. On the right side, after training, the model is used to predict the category of new unseen image, a new cat image in this case. The model predicts on that the image belongs to the cat class based on the features it learned from the label data. The prediction result is labeled with the class it identified. Here the label is cat. So that's all today. We'll see you in next video. Thank you.